Hey everyone, so let's solve this Leetcode medium problem, a maximum total from optimal activation order. So like the problem statement is like pretty vague here. So let's go through the problem statement, then I will explain you what the question is stating. So we are given two integer arrays, value and limit, both of length n. Now initially all the elements are inactive and we can activate them in any order. Now to activate an inactive element at index I, the number of currently active elements must be strictly less than limit of I. Okay, so we can only activate when the number of currently active elements is less than limit I. And when we activate the element at index I, it will add value of I to the total activation value. Okay, so when activating a single element, we'll be getting the total activation value increased by this value of I. Now after each activation, if the number of currently active elements becomes X, that means as soon as the number of currently active elements becomes less, then all those elements for which this limit of j is less than or equals to x will become permanently inactive. Permanently inactive in the sense that will not be able to activate them again. Okay, so even if they are already active, it will become permanently inactive. Okay, or if they are inactive, then it will remain permanently inactive. Okay, so this is the thing. Now we need to return the maximum total we can obtain by choosing this activation order optimally. Okay, so the first thing that we need to see here is we need to make sure that the number of currently active elements must be strictly less than limit of I. So suppose instead of this we had like if this is the limit, suppose this, so if we consider the smallest limit, because there is a chance that if this limit of j becomes less than or equals to x, then the entire means this all the elements corresponding to this limit will be becoming permanently inactive. So the first thing that we can observe is to avoid permanent inactive. What you can do is we can means permanent which elements can become permanent inactive for those elements whose limit value is very small, because as soon as this x increases, these numbers will be, if they are small, then they will become inactive. So we can means process smaller limits first. Okay, this is what we can do. So we can process smaller limits first. So this is the first step that we can think of. So what you can do is we have the limit as 1 initially. So if the limit is 1, that means the currently active elements initially is 0. Now if the limit is 1, the total sum that we have will be getting increased by this 5, because the currently active elements is 0 is less than this limit, hence we'll be able to activate this particular element. So total sum will be getting increased by 5. This currently active elements will be getting increased by 1. And now as soon as we see, like after each activation, if the number of currently active elements becomes x, so currently active elements becomes x becomes 1, so all those elements whose limit is less than or equals to 1, less than or equals to this currently element, that means this, since 1 is less than or equals to 1, so this will be becoming permanently inactive. Okay, so this has been now removed and sum is currently 5. Now let's say to process the second small limit, so we have 2. So what we'll do, we have the two currently active elements. Since all the elements become permanently inactive, so it will again become 0, because all those elements have become currently inactive. Now for this, the sum will be getting, since the currently active elements is less than 2, so it will be getting increased by 3. And since we have the total active elements will become 1. Okay, now this is currently active. Now if we process this element 3 with limit 3, so we see 1 is less than 3, so we'll be able to activate it. So we'll be able to activate it and we'll adding the sum 8. So we'll add the sum 8 and we'll get, means this is what we'll get, and the total number of active elements will become 2. So as soon as the total number of active elements become 2, what will we see? We can see that we this means since 2 is less than or equals to 2, so this element will be becoming permanently inactive, and finally the total number of active elements after this will be becoming 1, which is the active element 3. And since we can means activate L element at most once, so hence that's why the optimal means sum that we'll be getting is the entire sum of this array, which is simply 16. Okay, so this is how we'll be processing. So one thing is clear, that to avoid the permanently inactiveness of smaller limits, we will try to means process the smaller limits values first. Suppose in this case, if it process this second limit first, 2. Okay, so as soon as we make this active, this was 2 1 3, so as soon as we make this active, the currently active elements become 1. Okay, so as soon as these currently active elements become 1, since this one is less than equals to 1, this will become permanently inactive. So hence we'll never be able to add this particular sum in our total sum activation. Okay, for 2 we'll be getting 3 plus, but we'll not be able to add this 5 to our result. Okay, that's why we are trying to means start from the smaller limits, so that this becomes clear that they are not becoming permanently inactive. Okay, so I hope one thing is clear now. Let's see another input. So we are given the limits as 1 1 1. So we see the limit is 1. So currently active elements initially is 0 and sum is 0 initially. Now we have the limit 1. As soon as we means activate any of the elements, so since for 1 we have 3 elements, so let's try to activate any. Suppose I activate this one. So for this the sum will be getting increased by 4 and the currently active elements become 1. Now when the currently active elements become 1, for these two elements this 1 is less than or equals to 1. So these two elements will be becoming inactive. Okay, these two elements will be becoming inactive and will simply stop, because we have means these two elements become permanently inactive and we have already activated this particular element. So we have processed all elements and will not be able to means activate any more elements. So in this case, like if we try to activate this element first, we'll be getting the sum as 4. So what observation we can make here is, if we have multiple means elements with the same limit, then we'll be able to process, suppose this was 2, 2, 2, 2, and then we have 4, 2, 6 as the limits. So let's try to suppose means first we activate this limit. Okay, so the current active elements become 1 and the sum will be increased by 4. This is good. Now since currently active elements is 1, it is less than means the 2 is greater than 1, so we'll be able to activate one more element. So let's try to activate the larger one. So we activate this particular element. So as soon as we activate this particular element, the total number of currently active elements become 2. This will be increased by 4. So 4 plus 6, and since the currently active element becomes 2, so since for this element 2 is less than or equals to 2, so this will be becoming permanently inactive. Okay, so we will not be able to process this particular element for means activating. So hence the sum that we will be getting is simply 4 plus 6 equals to 10. So what observation we can make here is, for a particular limit value, if the limit value is simply L, then we'll be able to activate only the what? Top L elements. Okay, we'll be able to activate only top L elements. For example, here limit was 1, so we can activate any one element, and what element we'll be choosing? Since we want to maximize the total sum, we'll be activating the element with the maximum value. Okay, similarly for 2, we can activate only the top 2 elements. So top 2 elements will be simply 6 and 4. So 6 plus 4 is equals to 10. So we'll be means activating elements in increasing order of L, means increasing order of this limit, and for each limit we'll be able to activate only these top L elements. Okay, so this thing is clear. Let's try to apply this algorithm to this test case. So we are given the smallest limit is 2. So for 2, since we'll be able to activate at most 2 elements, so since there exists only one element with limit 2, so we'll be able to activate all of them. So we'll be increasing the sum by 5. Okay, so for this we'll be getting the sum as 5. Now for 3, we have 3 elements with limit 3. So we'll be able to activate at most 3. So hence we will be able to activate all of these 3 elements. So it will be simply 4 plus 1 plus 2, and hence the overall it will be simply 5 plus 4 plus 1 plus 2, which is simply 12. So the observation that we make here is simply, to first step was to avoid the permanent inactiveness of any element. So for that we try to process the elements in the basis of increasing order of limits, so that the smaller elements does not become permanently inactive and we are able to utilize their value. And after that what we try to do is, once we have grouped on the basis of a particular limit, we saw that we can, for a particular limit, we can only activate the at most that limit value of elements. Okay, for 1 we'll be able to activate only one element, because as soon as the currently active elements become 1, all the elements 1 less than or equals to 1 will become inactive. As soon as we reach x, if this all the elements whose currently active elements is limit is less than or equals to x, so all these limits will be becoming inactive. Okay, so if like L is, if we had, suppose this example, if we had 3 3 3 3 3, okay, and we had the values at 100 10 20 30 40, this was the values. So obviously for these 3 elements we'll be able to, since for limit equals to 3 we have 5 elements, so we'll be able to activate at most 3 elements. And what 3 elements will be choosing? We'll be choosing the top 3 elements. The top 3 elements will be simply 100, 30 and 40, and that will be the maximum sum of value that we can get in this. Okay. So I hope the algorithm is clear, the logic is clear. Now we just need to implement it. So what do we want? We have, means let's see the constraints here. So we have like the limit can go up to from 1 to n, and the length of both values can go up to 1e5. Okay, so what do we need to do? We need to process in the basis, means by grouping on the basis of limits, and then for each limit find out the top limit of I values and then take it as a part of sum. So what do you want? We can simply, first we need to group it on the basis of limit. So for a particular group we have, suppose, this vector. Okay, so we'll be having this vector. Now we create this map. What do we want? We now, based on this particular limit, will have all the elements who have this limit, and we'll be storing the indices so that we are able to find out the sum of values. Okay, or we can simply store the values for this. And now in this vector, what do we want? We want the max limit of I values, where this is the limit of I. So we'll be storing for each limit of I and all values of I, and then we'll be taking the maximum of limit of I values, or if it is less, then we'll be taking all of them, and we'll simply take the sum. Okay, so we can simply iterate from limit equals to 1 till less than equals to n, and for each limit we'll see in the map whether means there exists some elements or not, and then take the sum accordingly. By sorting it, we can simply sort it on the basis of decreasing order and take the top limit of I elements. Okay. So I hope the logic as well as algorithm, means the problem statement was pretty vague. So we try to, means first we need to understand that as soon as this permanently inactive, means we'll not be able to activate them at any instance. And another thing is that once we activate or inactivate a particular element, we'll not be able to activate it one more time. Okay, so we can only activate an element at most once. So like there is a ambiguity in the problem statement, but this is what it was trying to say. So let's see the implementation. The implementation is pretty simple. What we'll do, we'll create a map for each limit storing all the values of I. So we'll create the groups. For groups of limit of I, we'll be pushing its value. Now we'll initialize the total max. We'll be taking the sum. Now we iterate for each L from 1 to n. We'll see if some value exists for this L. So if it doesn't exist, we'll simply continue. Now if it does, we'll simply sort it on the basis of decreasing order, so that we are able to choose the top, means limit of I elements, so top L elements. So top L elements will be simply, if like L, if the number of elements in group of L is less than L, then in that case it will be simply the number of elements that will be changing will be the entire size of the group. Okay, so the count to take will be simply minimum of L and the groups of L dot size. We find the count to take, and we'll simply iterate through this groups array to find out, means to increase our total sum, and then total return the total sum. So obviously the time complexity of this would be order of n, and overall this means iteration will be happening order of n, as well as this sorting will be overall order of, means l log n, l log n, l log n. So overall it will be n log n. Okay, so this will be like overall the time complexity would be order of n log n, and we have used order of n space here as well. So this will be like the most optimal approach to solve this problem. We first need to, means derive the greedy approach, or like how will be, means we needed to group on the basis of means groups and create groups on the basis of limits. And as soon as we did, we saw like for a particular limit we'll be able to create at most, means choose at most limit of I values. So from that we derived that we'll be taking the top means maximum limit of I values, so that our sum is increasing by a maximum value. So let's try to submit this code here. This is the same code that we discussed. Let's try to submit it and see whether it gets accepted or not. The same code that we discussed. Let's see. It is taking a longer time. Yeah, it beats runs in 274 ms and beats 45% of solution. So it is like pretty fine. So yeah, this was the overall discussion for this approach, and if you were able to follow along, then make sure to like as well as subscribe. And if you yet have any doubts remaining in any of the parts, then make sure to comment down. I will be happy to respond. Thank you so much for watching.